Hello and welcome to Maths and Physics for You. Today we're going to plot the graph of y equals 3 sine minus 2x. This is an example of plotting trigonometric functions. We know that trigonometric functions, they are periodic functions, means they repeat themselves. They are wave functions. That is, they repeat themselves like a circle, goes round and round, okay, and see waves and so on. Okay, so in this example, x has the domain, the angle x, so x is the angle in radians in this case, minus 2 pi to 2 pi. In some questions they may give you not in radians, in degrees, that is minus 360 degrees to plus 360 degrees. Alright. In this example, we can say that the amplitude A is 3. This is the number in front of the sine function. So this is 3. If this was 5, then the amplitude is 5. It shows you the maximum value of the function in this case. Okay, so as we said, A is the amplitude 3 in this case. So we plot it straight away on the y. So this is plus 3 and this is minus 3. Okay, and because we are given that x is between minus 2 pi and 2 pi, so we put here minus 2 pi. Alright, we got minus 2 pi. We have here, let's say, here you got plus 2 pi. Okay, half of that, let's break it into, so this is pi, and this is pi over 2, this is 3 pi over 2, so we divide into halves. This is, let's say, minus pi over 2, minus 3 pi over 2. Okay, so this is the first thing to start with. Alright, and it will help us with construction lines like that. We plot construction lines. Alright, yeah, okay. Now, as we can see, if it was y equals sine x, if it was y equals sine x, that is the basic function, y equals sine x, or 3 sine x in this case, then it would be like that. Starts from 0 and goes like that. As simple as this. This is y equals 3 sine x. That is the same like sine x but multiplied by 3. That is, there is a dilation factor along the y-axis by a factor of 3. That is the amplitude. Okay, but now we don't have sine x, we have, let's say, sine 2x. Okay, so for this function now, we have a different period. For the sine x, the period was 2 pi. This is the period. This is called period. Equals 2 pi. That is the full length of the wave. Sometimes they refer it as wavelength. Okay, but here in terms of time, in seconds, they call it period. So t is the period given by this equation, 2 pi over b. What is b? b is the coefficient in front of the x. This is b. This is the coefficient in front of the x. This is b. So in this situation, b is 2. b is 2, this number. Alright, so this means that 2 over 2 cancel, and the period for this function here above is pi. The period is pi. So the period is pi, it means the wavelength is pi, that is, it's smaller. So for y equals sine x, the period was 2 pi. This is for y equals sine 2x, but for y equals sine 2x, it's half of that. So we go with that. Let's now use the blue color. Okay, so this is the period now. Alright, from here to here. Okay, so let's start there. So this is half the period, half of that, half of half. We plot like that. See, and on this side we continue. Alright, see what we have done. Okay, so the wave again starts from 0. Okay, we draw construction lines. On this side as well. Okay, let's see now what is the effect. We start at 0 because sine x or sine 2x is the same. They are 0, so that now we got squashed. It goes like that. Alright, half of it. So as you see now what we have, the wavelength is half the one for y sine x. This was y sine x, alright? But this is for y sine 2x. So this is matter of fact, there is a 3 here. Alright, but this one, no, this is our function, continues up. If you want to go up, alright, so that goes actually up to this point. So this is for on this side, here goes to this point, then to that point. Alright. Okay. Okay, so that's this is y equals 3 sine 2x. As you can see, we have 4 waves now. We have 4 waves instead of 2 waves in this domain, right? Everyone understands? Oh, that's very good. Yeah. Okay. So we go to the next step. We have sine minus 2x. So what do we have? All right. A glass of water later. Thank you. Okay, so minus means reflection about the x-axis. Okay, now the final plot is for 3 sine minus 2x. So now we done y equal 3 sine 2x. So the minus means the graph of y equal 3 sine 2x is flipped or reflected about the x-axis. So it has the same shape, but it's exactly reflected about the x-axis. So from here, this is what we can do. So this is the blue one. Okay, start at 0. This one is reflected about the x-axis, so it goes there instead. So that goes like that. This one 0, so nothing happens to it. This blue one goes up there, so this one continue like that. This one is 0, so it goes like that. The blue one there flips down, so like that to the 0. The blue one goes up, okay, there, and then back to 0. So this is on this side, okay, so that's y equals minus. With 3 sine okay, yeah, all right, because sine minus sine minus x is negative sine x. Yeah, so the same thing on this side. This goes up to this point, and there, and there, as you can see. Then back to 0, and this blue one goes up. So this is flip there, back to 0. All right, this one goes there to that point, and we go back to the 0. And there you have it, folks. This is y equal 3 sine minus 2x in the domain of x between minus 2 pi and plus 2 pi. Thank you for watching, and please subscribe. If you have any question, please write any comments so that we can explain more. Thank you.